Hi guys, today we'll be doing a revision or review on different types of triangles and common angles. So first thing I want you to do is to write down this table here on your right. So this is a table of triangles that are classified by using their sides. So for a triangle that has three equal sides as indicated by these lines, we call it equilateral triangle. And take a note that all of these angles here are 60 degrees and they're all equal because 60 degrees times 3 is 180. So angle sum of triangle 4 is 180 degrees. So that's why it's 60 degrees. Next, we have isosceles triangle. It has two equal sides. And just adding a note, the base angles would be the same. And lastly, we've got scalene triangles, which has no equal sides, meaning all of these sides are different. So I will indicate it by using different strokes, meaning all these three angles would be different. Next, we have the column on our right. We are classifying triangles with, or by their angles. So a triangle that has three angles less than 90 degrees, we call it an acute triangle. An easy way of finding whether something is less than 90 degrees is to put the corner of a piece of paper on each of the angles and see if it is less, like it's smaller than the corner. So if you put the paper, like say on this angle, let's call it A. This is a rough drawing of the corner of a paper. You can see that the angle A is smaller than the corner of your miniaturized paper here. Okay, so right angle, second one has one angle with 90 degrees, and that's right here. Again, you can use that corner paper method that I've just told you, and if you put it on top, it should overlap. For angle A, it should be exactly 90 degrees. Lastly, we have obtuse triangle, where one angle is larger than 90 degrees. So if you put the corner of a paper here, it will, my rough miniaturized paper right here, it should exceed the corner of the paper. Now, after we've revised the different triangles, we're going to look at the different angles. So these are some common ones. I'm just going to cover some common ones, yeah? So you can write down this table, common angles. Now, first one we've got is adjacent, meaning that the angles are next to each other. So if you look at angle 1 and 2, they're next to each other, meaning they also share a side or an arm. Now, if I go and write another, add another line here, and I call this 3, angle 3. Now, angle 3 and 1 are adjacent. Angle 1 and 2 adjacent. See, between 3 and 1, there's a shared arm. Between 1 and 2, there's also a shared arm. Now, how about 3 and 2? Do they share an arm? No, they don't. Are they next to each other? No, they're not. So 3 and 2, they're not adjacent. Next, we've got vertical. Vertical happens when you got two lines that intersect each other. So we got, when two lines meet, this point we call it intersection point, and we after in your intersection there will be 4 angles, and the opposite angles are the same. So 1 and 2 are the same. 3 and 4 are the same. Next, we have complementary angles, meaning when you see complementary, you just go directly, just think 90 degrees. That means angle 1 and 2 equals to 90 degrees. Supplementary, when you see the word supplementary, you immediately think of 180 degrees, and basically it's all the angles on a straight line. Yeah. So angle 1 plus angle 2 would equal to 180. Now there's one more angle that it's in this table, we see it all the time. So angle at a point. Pretty sure you guys know this already. So let's say this reflex angle here, let's call it this reflex angle plus the internal angle right here. Let's call that, you know what, I'll just use numbers because since we're using numbers here in general, so I'm just call this 1, I'm going to call this 2. So and in this case, angle 1 plus angle 2 would equal to 360, and you would call it angle at a point. So there we have it. We have the common types of triangles and the common angles. I'm going to do a few examples here. Now, question A. Immediately when you see a right angle, I think of 90 degrees right away. So A would equal to 90 degrees minus 70. And we always need to give a reasoning. In this case, it will be complementary. So referring to the table on the top when you don't remember which reason to use. Now, question B, at a point. So A would equal to 360 minus 130, and then that gives you 230 degrees. And you're going to write down the reasoning. Angle at a point. Question C, when I see a straight line, I immediately think of 180 degrees. So A equals to 180 degrees minus 145 degrees. That gives you 35 degrees. And reasoning, supplementary angle. Yep, so like, oopsie. Okay, so as I'm just shorthanding everything. If you write it out, please write it out in full. And question D, when you have an intersection, you have 4 angles and the opposite ones are the same. Yeah, so A would equal to 41 degrees and your reasoning would be vertically opposite angle. E, when I see a straight line, I go immediately into supplementary, meaning I think of 180 degrees immediately. And then, so 9A equals to 180 minus 75. And right here, we've got 90 degrees, so we minus 90 degrees. We got 15 degrees, and we write down the reasoning, which is supplementary. Cool. Last F. I know we've got, it looks like an angle at a point, but we have a simpler solution to this. See this corner right here, that gives you a right angle, and when we see a right angle, I think of complementary right away. So we don't need to use angle, or angle at a point. We can just use complementary. So 90 degrees minus 52 degrees, that gives you 38 degrees. And always writing the reasoning, which is complementary angle. So hopefully you'll remember a bit better review on this